Hello everyone. I will try to see a series of lectures which are searching and sorting techniques. So for example, we have a group of element. On this group of elements, we are going to apply some kind of technique to find the element. So that is nothing but searching. If you are going to arrange your elements in a particular series, either it could be ascending order, either it could be descending order. So that is going to be sorting. So now we'll try to see searching, then we'll go for sorting of your elements. So what do you mean by searching? Searching is nothing but finding an element from a given set, right? If the element is found, we are going to say that element is found in the from the particular given group. If the element is not found from a particular group, so then we'll call it as the element was not found in the particular representation. To identify a particular element, so we need to do some kind of a comparison. By doing comparisons, we are going to identify the particular element, whether it is available or not. We are going to check by doing some kind of comparisons. So how these comparisons will be happen and what could be the techniques we have. So before going to that, we'll try to see that why these comparisons are going to be considerable. So why? Because for example, I'm having a group of element that is n. So to find the element which is available inside my array. So for example, I'm the last element inside my particular array. So how many comparisons I need to do? To find this, I need to do n-1 comparisons, right? Second, for example, I'm having n element. So in this n element, my element was identified at first index position. So how many comparisons I am going to do? I am going to do only one comparison, right? So because where your element is represented, so depends on that your comparisons are going to be increased. So this is may leads to produce some kind of complexities if you are having large data, and maybe if you are having a small data, there is no problem for your comparisons. So depends on these comparisons, we are going to introduce some kind of new techniques. So we'll try to see very basic techniques which are available to search your element. One is a linear search and second one is binary search, right? One is linear search and another one is binary search. Linear means we need to do in the sequential order, and binary means there is some kind of special strategy we had. We are going to say yes or no. So based upon this yes or no, we are going to find the element from your given array. So as per your ideology, I'm going to give linear search will give time complexity as order of n, and binary search is going to give a time complexity as order of log n. So this is the strategy we have. So now we'll try to see very basic approach, linear search, how it is going to work. Then we'll go for binary search. So before going to this binary search logic implementation, we'll try to see that what could be the strategy we are going to see. To apply any kind of searching technique on your linear search. So by using this linear search, if you want to find an element, first we need to have a group of element. So we need to have group of element. To represent group of elements in our programming representations, we had a concept called array. By using array, we can create n number of index positions to store your values. And after this, I'm going to have some kind of searching element. So this X is a searching element which is used to look into your array to trace that whether this element is available inside your array or not. So now what we are going to do, how your searching will be happened inside your linear representation. Linear search is also called as a sequential approach. So in the sequence, we are going to retrieve your values one by one, and we are going to do the comparison with your X value. So that means you are searching element. So if the element is found, we are going to say that the element is found. If it is not, the element is not found. This is the only strategy we had on your linear search. So we'll try to see one kind of example. So in this example, we are having some kind of set of element. The elements are going to be represented as 10, 20, and I'm having 30, 40, 50, 60, so enough. So now I'm going to represent some kind of searching element to 50. So I'm having a 50 element, so I'm trying to find the element. So what I'm going to do in the linear search is going to be happen with the sequential representation. We are going to search for your element by doing a comparison with the starting index, and if you have found the element, your search will be stopped. If not, you are going to look for next element. Like this, we are going to look for next element, next element, next element until you are finding the element. So here what we are going to do, first we need to retrieve the array value. We need to do the comparison. If the element is equivalent, then we can say that found. If it is not, the element is not found. So step 1 I'm going to do, I'm going to retrieve a of I value equals to x. My x value is 50, and first I'm going to start with the 0th index. So 0th index. So a of 0, it means what? 10. Is it 10 equal to 50? No. So I am searching for 50, but it is not 50. Now I am going for a next element, that is 20, right? So that is going to be 20. So next index position is 1, and we are going to look for 20. 20 is equal to 50. So this is also false, and I am going to retrieve next element 30, and I am going to compare with 50. So whether this 50 is equivalent to this? No. So we are going to increment your index position by 1, and we are going to reach to 3. A of 3 is 40, and 40 is equivalent to 50. Condition false. Next, I am going to increment my for loop, that is going to be 4. A of 4 is equals to 50. Condition true. So I found my element. This is my kind of a scenario. So where element is found. Maybe there is a chance the element is not going to be found in the given array. So that is also possible. So now we'll try to see a simple algorithm for this linear search representation. So first we have to traverse the array elements using a for loop. Yes, we require some kind of set of elements, and which are going to be retrieved one by one by using a for loop. And for every iteration we are going to use your index position to retrieve the value, and the value will be compared with your searching element. If the searching element is matches, then we are going to say that element is found. If the element does not matches, then move to the next element. If there is no match or no searching element, we are going to represent that your element is not found in the given array. So simple representation for your linear search is, we are going to retrieve element by element, and we are doing comparison with the searching element. If the element is found, we are going to say that the element is found. If the element is not found, we are saying that element is not found. Here there are the best cases for this best case for your linear search is order of 1. If your element is represented in the first position, so then we are going to say that order of 1. If your element is going to be represented at last, right, that is going to be order of n-1. So we are not going to worry about your negative or constant values. The time complexity will be order of n. So this is the strategy we had on your linear search. So we'll try to see what could be the program we will write on this linear search. Then we'll try to go for right. So right. So now I will try to see some kind of strategy and how to implement some kind of a C program on this linear search. So first I'll try to use some kind of hash include stdio.h. Then we are going to represent some kind of main function. So in main I'm writing like this, or you can use void main also, depends on your compiler. And then what we are going to do, we are going to create some kind of array int a. So instead of giving the values from your scanf, I'm directly giving your elements 10, 20, 30 and 40. next 50. We had some kind of elements like this. So after this we are going to create some kind of variable to find your element, int x. So int x is used to store the element which you are going to find. So I'm going to write a scanf statement and I'm going to scan the value from your console. For this I'm writing scanf statement, and after writing this my linear search has to be happen. So for this I'm going to use one more variable, that is count variable. You may use, you may not use, it doesn't depends, it depends on your logic. So I'm using count equals to 0. So this is going to be my representation. Then next I'll go for a simple representation of for, and which is going to consist int I equals to 0 and I less than or equals to I less than n and I plus plus. So I'm having this. Next what I'm going to do, I'm going to write a conditional statement because I'm retrieving the element by using your index positions one by one. So now I'll try to do some kind of comparison. If a of I equals to x, I'm searching for the element x, so I'm comparing. If that is true, I can say that your element is found. So if the element is found, I am not going to do any kind of searching further. So if printf I'm writing, so to print that element is found, right? So this is your strategy. So after this I'm going to write some kind of variable count. So I'm making it as equals to 1 and I'm closing this. After this I'm going to represent, closing this, and before going to this I'm going to write one more representation, because after finding an element I don't want to compare further things. I want to stop this logic execution. So for this I'm writing break. So if I'm writing break, what will happen? It will come out from your for loop, right? Whatever the logic you have after this for loop, it will execute as it is. Now I'm going to do if count variable is equal to 0, or just assume that if count equal to 0, we can say that your element is not found. So to print this I'm writing element is not found. So this is one kind of strategy I'm going to write. If you are interested, you can follow this. Thank you.